Today we're going to solve a classic mathematical game known as the Tower of Hanoi. In this, we have 3 pegs and a certain number n rings. And the rules are we can only move the top disk from each peg, and we can only move a disk to the top of another peg. And also we can only move one at a time. There are 3 pegs, A, B, and C, and all the disks are initially stacked on A. And the objective is to get all the rings to the rightmost peg, C. So for the optimal solution for 3 disks would be to move the top to C, move the middle to B, move the red to B, move green to C, move red to A, move yellow to C, and move red to C. And in the example, our first steps brought us so that the 2 rings are on the peg B, and the largest is on peg C. And to do this, we first moved the smallest to peg C and then the middle to peg B. And after that, we moved them all over to C by moving the smallest to A, the middle to C, and finally the smallest to C. So we can basically break this up into smaller subproblems. To solve it as a whole, we'll move n-1 disks, so all the disks besides the bottom one, to the middle peg. And then we'll move the bottom one to the target peg, which is C. And then finally, we'll move our n-1 rings back to the target. And we can define each subproblem as moving the n-1 rings from the target to the auxiliary. And we can keep recursively calling this problem to construct a complete solution while the number of rings is greater than 0. Now we can implement this in Java. So I'm going to create our recursive function, which is going to be called move. And we're going to have a few parameters which we want to pass in. We have a character of our source, our target, and our auxiliary pegs. And at first, source is just going to be A, target is C, and auxiliary is B. In here, we want to check if n is greater than 0. Oh, and we also have to have the number of rings. Forgot that parameter. If n is greater than 0, that means we have at least 1 ring. Then we're going to move the n-1 rings from the source to our auxiliary using the target as our auxiliary peg. Now we can print out the move that we are making. I'm going to say move disk source, n from source to target. So we're going to move the ring to the target. And finally, we're going to move the n-1 disks back to the target from our auxiliary, using the source as our auxiliary peg. So now I can define a scanner. And the number of rings is going to be scanner.nextInt. And I can call move on n, A, C, and B. Let's run this and see what happens. I'm going to enter in 3 rings. And we see we get the correct result. Move disk 1 from A to C, move disk 2 from A to B, move disk 1 from C to B, move disk 3 from A to C, and so on, until finally we move the last one from A to C, and now all our disks are on the target peg.